So we are going to simplify this rational expression. In order to do that, we need to factor the top and factor the bottom. So for the top, I notice there are two terms, and I notice there's a GCF, a greatest common factor. So that's what I'm going to start with. And what I notice between these two pieces, there is a 3 and an a in common. So 3a is your greatest common factor. All right, that is the numerator. Now our next thing is, let's put the GCF out. 3a times what will give us this, and 3a times what will give us that. And if you think about that, what we'll notice is this has to be a, and this has to be minus 4, because 3a times a is 3a squared. 3a times negative 4 is negative 12a. This cannot factor anymore, so the top is done. Now I also want to factor the bottom, all right, if I can. And first, what I like to do before factoring, I actually like to put it in standard form as well. So let's put this in standard form to start with. So standard form would be the a values go first, and then the number 12. All right, but that's not factored now. We can actually, for this, pull out a negative 3, or just a positive 3. But what I see is a negative 3 being a better option. So I'm going to rewrite the top, which is 3a, a minus 4, and on the bottom, I'm going to pull a negative 3 out. All right, so when I pull out that negative 3 times what will give us this, and negative 3 times what will give us that. So let's see what we get here. When we pull that out, I see that would be negative 3 times a will give us negative 3a, and negative 3 times negative 4 will give us positive 12. And what you now notice is this disappears, because anything over itself is 1, and that would leave us with 3a over negative 3. But that's not fully done, because can't these 3's disappear, creating a negative 1? So my answer is negative 1 left, or let's just say this. It'd be a over negative 1, maybe the best way to look at that, which is negative a, or negative 1a, would be your final simplified expression. All right, next. State the restrictions of this expression. Well, the restrictions are what makes the bottom 0. You don't even care about the top. I don't even care. It doesn't make anything for restrictions. Restrictions are the excluded values that cause issues, so that's the bottom here. So what we're going to do is we're going to factor the bottom to do this. So to factor the bottom, I am going to multiply the front and the back. That'd be negative 6. Put the 5 on the bottom. And I'm thinking of two numbers that multiply to get negative 6 and add to get 5. Now be careful on this one. A lot of people would do 3 and 2, but that does not work properly. Okay, so be careful on that. So what I have here is 6 and negative 1. Now, so what I'm going to do, I'm going to focus on the 3v squared and the minus 2 in the back. But in between, I'm going to change this 5v into a positive 6v minus 1v. All right. Now, from there, I'm going to use grouping to factor it. So I'm going to do the two groups, and I'll pull a GCF out of the first group, which is 3v, and I'll pull a GCF out of the second group, which is negative 1. Once I do that, 3v times v will give you 3v squared, and 3v times positive 2 will give you 6v. And then negative 1 times v will give us negative v, and negative 1 times positive 2 will give us negative 2. Lastly, we're going to take these two pieces, pull them out as a GCF, and we are going to leave these behind, so it's the second term, which is 3v minus 1. Now, why did I do all that? Well, this is the factored form of the denominator. And we want to know when this equals 0. That is the whole point. We want to know when this equals 0. So in order to do that, we have to factor it. Okay? And we just factored it. So now we set each factor equal to 0 and solve them. So when I take each factor, I set them equal to 0 and I solve them. So this one would be a minus 2 over. So v equals negative 2. That is one value of v that is restricted because it created 0 in the denominator. All right, and the other one, we'd have to add the 1 over. Gives you 3v equals 1. And then I divide by 3 here. All right, cross those out, and I get v equals 1/3. So these two values would create a 0 in this denominator, and they would be restrictions because we are not allowed to divide by 0. Alrighty, in order to solve this rational equation, what we do is we multiply by the lowest common denominator, both sides. But for a lot of people, they struggle with what is the lowest common denominator. So I found a way that, a little differently, I just take the denominator with the most stuff and multiply by it. And then I slowly do that over and over, and sooner or later, it will work like the lowest common denominator. So which of these denominators has the most? This one does. It has an x squared and a 3. So I'm going to take this and multiply both sides by it. And when I multiply both sides by it, what that basically ends up being is you're multiplying all parts by it. All right, so we're multiplying all parts by 3x squared. That's basically what's happening here. And when you do that, the x's will cancel for that one, leaving you 1 times 3x, which is 3x. Here the 3 will cancel, and so will the x with that power, leaving you minus 4 times just the x. Again, let me kind of clarify that. That squared has x times x. So one of the x's cancel, leaving you singular. 3's cancel, and I have this piece, the minus 4 and the x. All right, let's keep progressing on this. So you have equals. Now for this one, the whole thing disappears, leaving you an x minus 2. So, whoa, 3x squared was your lowest common denominator. We're done. But sometimes you have to do this again to get rid of more denominators. Okay, so now all denominators are gone. We solve. And to solve this, we are going to start with cleaning up each side. So I'm going to combine these. A 3x minus 4x is a negative 1x. Leave the x minus 2 over here. And let's solve. So let's move the x's to the left. So I'm going to minus the x over. That would leave me a negative 2x equals negative 2. And when I divide both sides by negative 2, because I'm trying to solve to cross that out, I get x equals negative 2 divided by negative 2, which is positive 1. Now, is that my answer? Well, it is, but is it extraneous? Will that answer create a 0 in the denominator? So let's check. What are my restrictions? Well, my restriction here would be 0, because 0 would create a 0. That would be a 0 as well, and that one's 0. So my restrictions are x cannot equal 0. And since my answer is 1, which is not 0, we're good. My answer 1 is fine. It's not going to be restricted. All right, so the next problem. Here we go. We want to solve this one. We're going to kind of do the same process, but this has some factoring involved. All right, so we want to multiply both sides by the LCD or just the biggest denominator, the one with the most stuff. So I notice these two are the same and I have this one. So probably these are the ones we're going to multiply by. But before I do that, I actually want to multiply by a factored version of it, because I don't like to just do multiply by that ugly standard form quadratic. So if I factor this real quick, what will we get? Well, let's put negative 12 on top, 1 on bottom. And if we think about that, won't that be a 4 and a negative 3? So what I realize is I can replace both of these with a plus 4, a minus 3. So I can cross that out and replace both of these with a plus 4, a minus 3. That's going to be helpful. And what I'm going to do is I'm going to take that and multiply all sides by it. All sides. So a plus 4 times a minus 3. All right, this one's going to be a plus 4 times a minus 3. And this one's going to be a plus 4 times a minus 3. I multiplied both sides by this, which means all parts. And as I do that, watch what happens. Doesn't this eliminate? And so is this, leaving you simply 1. Plus, doesn't this eliminate with that, leaving you a 5 times a plus 4. Equals, doesn't this eliminate, and this eliminate because they both create 1s, leaving you simply 3. And we only had to multiply 1 time. Sometimes you have to keep multiplying by denominators to slowly get rid of pieces 1 by 1. All right, this one's ready to solve now. So let us solve this. First thing I want to do to solve this, I'm going to distribute the 5. So I have a 1 plus 5a plus 20 equals 3. Next, I'm going to combine like terms over here. I have 5a plus 21 equals 3. Now I'll minus 21 over. Once I do that, I have 5a equals negative 18. All right, and I divide by 5 now, and I get a equals negative 18 over 5. Now before I circle that and claim it, I have to look at the denominators and see what will create as 0 on the bottom. So my restrictions for this particular problem, my restrictions are what makes the denominator equal 0. And so what can it not equal? Well, it can't equal a negative 4 because that would make a 0 here. This would be a 3 would make this a 0. That's a 3, negative 4, 3. So it looks like negative 4s and 3s are my restrictions. So negative 4s and 3. And since my answer is neither of those, my answer is fine. So that is my answer, and that would be the answer to it.